Oh, hey here. I'm just in the middle of some ironing right now. Tuesday night about 10 o'clock. I realize I have a question that just came in about the Chapter 9 problem set. All right, let me put my ironing down. Let's go ahead and answer it because your questions I want to have answered. Okay, so this person's asking about the very last question on the practice handout, number 18, which actually all of a sudden had to do with not a quadratic, an exponential function. Now, this is from Chapter 7, y equals a times b to the x form. We know since x is an exponent right here that it's an exponential function and input-output relationship. So I'll have our y on the other side. Anyways, you got 2 points, 2, 3, and 427. That's what that exponential function is going to do. Now, one of the things in the problem here that you have to do is you have to sketch it out. So just quick reminders on that. You have to do that one. So let's go ahead and sketch it out right here. We have x, we have y. And you can maybe even sketch it out because this is kind of what it's going to look like. X is 2. We're up here at 3. And when x is at 4, we're way up here at 27. Now, you don't have to do it totally to scale. Just like pretend it's kind of big. And there we go. We got a point here. We got a point here. Now, if you remember exponential functions, they also have asymptotes. Remember asymptotes here. So 2 points is actually enough to sort of sketch this exponential function because that exponential function is going to connect those 2 points, and then it's going to flatten out. So it should be curved a little bit, and then it's going to flatten out towards the asymptote. Remember? And it's going to get smaller and smaller and smaller until it approaches 0 that way. The asymptote here, and then it's going to go this way forever. Okay, so why is this on the Chapter 9 practice review problems? Well, these questions have actually come up in the Chapter 9 problem sets quite a bit, where they give you 2 points, and they want you to practice this from Chapter 7, get it into y equals a times b to the x form. So this is actually in the textbook here in Chapter 9. If you go back and you go to page 443, that might be able to help you out. Okay, page 443, we have curve fitting and exponential function. They go through kind of the whole process where they say 2 points here, this point here, and this point here. How do I get the equation in y equals a times a times b to the x form? And they take you through it, okay? Well, for this one here, I might as well do the explanation for you here. My ironing can wait, right? I don't have to finish my ironing right now, so I might as well take you through the process, at least the way that I solve the problem. And it's a little bit different than the way that they write up here, although both of them work, okay? Here we go. First thing, step 1, we know here that coordinate pairs, an xy coordinate pair that's going to work in whatever equation we're going to generate is going to be 2, 3. So there's an x, there's a y, and also 427. There's an x, there's a y. We know that these equations, or the equation is going to be the form y equals a times b to the x form. Okay, I'm going to draw that twice. Why am I writing that twice? Well, you'll see in a second. Okay, because if I know this, I know a coordinate pair that works is 2, 3. Another coordinate pair that works is 427. I can replace x here with this x value in that coordinate pair, and I can replace y with its corresponding output, right? Well, what would have to get generated, if I had an equation here and I plugged in 2, I would get y as my output, right? That's why these points on a graph are just the outputs, right, when we have a given input for a function here. Remember, functions sort of describe input-output relationships where for every input, there's exactly one output. That's why they're coordinate pairs. They're paired up here. Input has that one and only one output. Okay, so I'm going to do that here. I'm also going to do this here. And because basically these problems here are just systems problems. Systems of equations that are exponential in this situation. My other coordinate pair here, remember, it's y equals a times b to the x form. So I'm going to put in 4 for x, and my output I get would be 27. If I knew what a and b would, it would spit out 27 because the equation is going to deliver that. I know that my equation is going to have those points on it. Those are going to be pairs of points that would work if I plugged in 4, and wherever a is, wherever b is, delivers me 27. Okay, so then the question is, what is that value of a? What is that value of b that gets me through the point 2, 3 and gets me through the point 427? Because through any 2 points, there's actually only exactly one exponential curve that can be drawn between the two, one that would be approach an asymptote and connect the two and keep growing. So anyways, what can we do to get there? This is a systems problem at the end of the day. So you have your systems methods. Remember your 3 system methods? Okay, your 3 system methods are equal values method. That's the way that the book kind of describes as using equal values method. You can read about it here on page 443. I recommend the substitution method. Equal values method, remember, systems of equations. Equal values method, substitution method, or elimination. Okay, can't eliminate here because we have some multiplication going on. It's kind of a little weird. Actually, you can eliminate through division. That's a little hint there. Eliminate using division. I'm going to use, instead of using elimination, I'm going to use substitution here, okay? So substitution, I don't have any of my variables here, right? So what I want to do is I want to figure out what A and B are. That gets me the right equation. I don't have either A nor do I have B isolated, okay? But I can isolate one of these variables a little bit more easily than the other variable. Okay, I can isolate my A variable here. Okay, so what I'm going to do through using substitution is I'm going to isolate A, and then whatever expression I get for A, I'm going to substitute it in for A into this equation. Here, see what I'm doing here. See if you follow along. Okay, how do I isolate A here? Well, if A is being times by B squared, so I can divide both sides by B squared to cancel out the B squared that's being multiplied to A, and so now I've isolated A. Okay, so what? I have this statement here. I know that A has to be equivalent to 3 divided by B squared. Well, why? It's an exponential function, and it was in this form to begin with. I'm just isolating A right now. Okay, so what can I do? I can now substitute, right? Substitute in. This is my substitution method. Substitute. Okay, I'm going to substitute 3 over B squared for A right here. Okay, so I'm going to go maybe move this over here, do my substitution. 27 doesn't change. Equals is still there. The A is just going to become this. Is going to become 3 over B squared. And then I have B to the 4th there. That doesn't change. So now, look, I have an equation here where I replaced A with an expression that I isolated in the last one. And this equation here only has the B variable in it. So can I solve for the B variable? You better believe I can, okay? So let's go ahead and solve for it now. 27 here, I can just bring that down. I can't simplify that at all, but I can simplify this side here. 3 over B squared times B to the 4th. Well, that's the same thing as 3. Remember, this is B to the 4th over 1. So I can just multiply my numerators, get 3B to the 4th, okay, and multiply my denominators, and I just have B squared down below, okay? Do you remember the rules? Do you remember laws of exponents? What do you do when you have the same base on the top as you do on the bottom? You subtract the exponents. That's right, you subtract it because two of these B's, cancel it out here, are going to cancel out 2 of the B's on top, okay? So you'd be left with B squared. You see that there? Well, hey, 4 minus 2 is what? 2, okay? 2 of those words. Remember, this is B times B times B times B, B 4 times in a row, and we're dividing by B twice. So 2 of those B's would crossed out in the numerator. So what I have here is 27 equals 3B squared, okay? B to the 4th divided by B squared is B squared there, and now I can go ahead and keep isolating, keep paring it down, okay? So B squared, do I want to take the square root yet? No, I don't, because I don't want to take the square root of 3. That's really, really ugly. I also don't want to take the square root of 27. That's not a perfect square, but let's check it out here. So what can I do instead? I can divide by 3, and I can get myself 9 is equal to B squared, and what's going to get me B now? That's right. Take the square root, okay? So I'm going to square root both sides, and here, you might be used to this here, putting a plus or minus in front, right? We've been doing that in the quadratic thing, because B technically, mathematically, could have been 3 or negative 3. 3 squared is 9. Negative 3 times negative 3 is also 9, okay? But I'm going to get rid of that now. Why? Well, an exponential function, right? You got to remember this from an exponential function in chapter 7. An exponential function is only exponential if B is a positive number, okay? That's the way it's only going to have a curve like this. Remember, B is negative. That means if B were negative, you'd have repeated multiplication of negatives, and then your graph looked all wonky, right? Looked all weird. It's jumping up and down. Okay, so B actually has to be positive here, so don't have to worry about positive or negative. So the principal square root of 9 is 3, and I got myself a B, so that's good. Do I have my whole equation? No, I don't, but I can go back here, and I can get this 3 equals A times by B, but instead of B, I'm going to put in 3. That's right. We're going to finish solving the system here, and this is to the 2nd power, and I'm going to figure out what my A parameter is, so then I can write my equation y equals 8 times b to the x form. Let's do it. Okay, so I got here 3 is equal to 8, and then 3 squared is 9, so I got 9a right here. Divide both sides by 9, and a is going to equal 3 divided by 9, which is 1/3. Okay, so I have my A, I have my B. Is that my final answer? No, you have to write the final y equals 8 times b to the x form exponential function at the very end of the problem, right? Because that's what it's asking about. So let's go ahead and do that. Y equals 1/3 times by 3 to the x power, okay? Thank you for the question. I'm going to get back to my ironing because, I never want to have, kind of too many wrinkles, right, in class. I don't want to look too bad in front of you guys here. Thanks for the question. I will see you guys soon. Bye.